Ladies and gentlemen, please welcome James Bagnell.
Woo, thank you, thank you, thank you. Thanks, everybody. Appreciate it. Don't be so enthusiastic there. Today I'm going to talk to you a little bit about the journey towards a totally self-driven IT environment and how we can take where we are today, which is in a pretty automated environment for the mainframe, and actually improve upon that and take it to that next step. And it actually does take a human being to assist in that specific effort. Much like the automation that I currently see to the right, where they are gently pulling a tap and there's a nice liquid flowing from that into a cup that we can actually partake in as an alcoholic beverage. What we're going to talk about today is a little bit really about evolving the mainframe data center and really getting to that point where we can be as self-driven as possible, but also provide productivity to users based on human interaction. So as we get into talking about different things around automation, it's always been a human interaction that has led to the creation of that auto type of environment. We look at that, we also talk about a lot of things, and we kind of lead this in of Ashok Reddy, our GM, has written this in a blog, but how we've gotten to and where we want to be from an automation perspective. One of my good friends is a corporate pilot for the University of Pittsburgh Medical Center. He's also an Uber driver on the weekends. And he actually picked up the lead person who was in charge of the Uber program in Pittsburgh for their self-driving cars. And so they got into a conversation. And the conversation was about, hey, so as a pilot, I know you have to do this type of things. I presume it's very similar in the car. And that the Uber management person said, yes, we have to do that type of thing. Can you come over here and work as a part-time tester for us to help us provide that next generation of self-driven cars? And so really what they were talking about is I had a discussion with him was the steps that was taken to actually record the actions of a pilot over many thousands and thousands of flights that has allowed them to get to the point of autopilot being essentially able to take off and land the plane. But with a human being there to make critical decisions on things that a system might not understand, the environment inside the cabin, of things that might be happening. So it's a similar type of approach that we're going to be talking about today, is how do we step from where we are today, in that next improvement to where we get to actually the automation and get to as self-driven as possible. So there's 6 levels that we talk about, which is level 0, where was the old standard car I grew up on. My kids don't understand what 3 on the tree means when we have the gear shift with the clutch, and really understanding and driving that very manual type of environment, to where we start to get to some driver's assistance. Cruise control was one of the first ones, keeping something at a steady speed, improving your miles per hour, consumption of gas, and then really starting to get into more of that partial automation. Over the last month and a half, I was assisting my mother-in-law in purchasing a car. And there was so many bells and whistles, some that I thought were beyond what she needed, but the type of things that they've added in to an environment that assist the driver in safety. She has forward emergency braking. In the event that your eyes are off the road for a second, you stop the car before it actually is in an accident. She has intelligent assisted cruise control, where that car can actually see 2 cars in front of them and understand what is happening, so that the car is actually kept at a speed at a safe distance from the cars in front of them. So as my wife and I were looking at cars, so my mother bought this car. We were looking at a very similar car. Being a little bit younger, we said, do we really need those extra bells and whistles? They're nice from a safety perspective, but it's not something my wife feels that she would actually utilize. So why spend the money? But the basis there is that the technologies that cars are bringing into the mix is very automated. And new things are being added every day to make it even more automated. We know that Tesla has a car that's self-driving. Tesla has unfortunately learned some lessons through unfortunate deaths of users of the technology. So how do we actually make sure that we get to a point that doesn't happen? As we get into partial automation, we start to understand that the car can start to do some things on its own. Really talking about the cruise control. Conditional automation, the forward emergency braking. You know, if it sees something, it stops. That type of approach. High automation. I always like the one commercial, and I'm not sure if it's for Ford, where the guy pulls up and he pushes a button, he takes his hands off the wheel, and the thing, you know, backs in and does the parallel parking. I wish I had that when I was taking my tests as a youngster, because that's the one element that everybody has difficulty with. So now I only make sure the parking spots are pull in or directly back in, so I don't have to actually do that extra function. We then get into that high automation, where we still are providing feedback as a user, so that the system starts to understand feedback of what we're actually telling the system that we want it to do. And then we get to that full automation, that utopia, where it starts to learn on its own, but it has learned that from the information that's been provided by the tribal knowledge of the person that's actually doing that. Same thing we have in the mainframe today. We understand that we have a diminishing workforce. The skills are retiring out of the business. I spoke to a young gentleman today. He was 28 years old, I think he told me. He said, I got 20 guys, they're subject matter experts. I'm going to have to know in the next 10 to 15 years everything that they know, and there's no way that I'll be able to absorb all that information. How can I take MOI, bring it in as a proof of concept, so I can start engaging my management to understand that this will assist me to be more productive a lot quicker. It will also, as you engage the automation, in this instance Ops and BS, allow us to get feedback and start to capture that knowledge, that legacy. I always talk about when I'm talking with the mainframers when we're in the room. You've been working here 30-some years. You've got a lot of knowledge. Let's leave your legacy here with the environment. Let's make sure that you leave something for those new people that are coming in to actually be able to take upon themselves and actually start to be productive a lot faster. And then the sixth, of course, we get to fully automation. So the data center, level 0, manually operated. We were talking about that with the car with the clutch, which you don't see much in America anymore. If you're in Europe, of course, it's very common. But actually manual steering. Who remembers having to be like Arnold Schwarzenegger to actually make a turn? You know, it was very, very difficult. My wife and I were just speaking about this the other day when we were reminiscing about our first cars and really understanding that. But, you know, the other thing is it's totally in control of that human being, someone making that stance. In this instance, in the mainframe environment, it was probably sitting in a console, hitting enter, waiting for a response, and making some type of decision. Excuse me. Sitting at that console, making a decision. We have a lot of that. We've created console tools to consolidate consoles to make those decisions. Now we've actually started to make that to the next step as we talk about some of the automation we have today. Data center level 1. This is really where we start to monitor. The automation package really starts to look at data, logs, issues that are occurring. But in reality, the only thing it did at that time was make a notification. Allow us to understand that there was something that I needed to actually go into my system and make a change about. So it was a notification. Very much like in your cell phone today, where I get notifications all the time. And then I have to make a decision. Do I read it? Do I ignore it? Usually I'm looking at it if it's my fantasy football scores, which are horrible because I'm last place in my fantasy league currently. But it's the same type of item where I'm actually looking at that notification, understanding what that notification is, and making a decision, and then taking some action. As we look at level 1, that really is still the old war room. We've notified of a problem. We're getting a lot of people in a room. Nobody can figure out what's going on. There's distrust on that notification. When I was working, and I use this as I notice all the time I talk about this, I worked in the graphic arts industry, and I was a production scheduler, head of all production for a multi-million-dollar magazine printing facility. and nobody could schedule work the way I could. It was a total manual process. They once introduced a scheduling system that would automate some of that. Nobody can do it as good as me. Until I left that company and went to work for the scheduling company and started to understand the technology. And this is the same type of thing that we've done in the mainframe, where we've now taken that time and now understand that automation can start to bring some of that capability to the mundane tasks and remove them. Now, we still do it in a manual way. We'll see an issue, we'll get together an automation team, we'll define some type of automation, and then we'll actually make a decision to execute that automation. So it's very manual from a perspective of those notifications, but it really starts to take us to that next step of partial automation. This is where we can actually start to do those simple tasks in a more automated fashion. Really get down to that root cause analysis a lot quicker, and really start to see the war room still be there, but actually understand and start to visualize some of the problems that we've had in the past. What are those things? As we do that, we start to get into conditional automation, where we start to talk about the sophistication of that automation. And this is kind of where we feel we are today. We've got a lot of automation in the mainframe environment. We've been doing automation for years. Process automation, IPL system, restart a Kix region, those type of steps. But those have come from the standpoint of having automation teams, being able to write those automation scripts, and bring those automation scripts into a production environment. We all know that those automation teams are starting to dwindle. So are the people that manage the CICS regions. We used to have experts in just CICS. Now they're usually doing multiple jobs. They're CSCS, they're MQ guys, they're IMS guys. They're now being asked to broaden their vision, and it doesn't allow them to get as deep as they need. So as we've brought automation into the mix, it really starts to allow that war room to start to become less active and really start to automate a lot of those processes, remediate those issues. We talk a lot about analytics. You'll see everything here from mainframe operational intelligence. And those presentation of information is fantastic. It allows you to do analysis. But the true value of what we're trying to accomplish is the remediation element of that. So as we get into discussions with other competitors that are outside, that are these big utopian offerings of analytics, this is the differentiating element that we bring to the mix. We understand that we need to remediate, not just understand and notify that there's a problem. So as we get into the root cause analysis here, we can now start to use static thresholds, which was used in the past, to actually start to trigger events, trigger automation. Go do this. If we look at the SysU product that we have, you can trigger a threshold to go off to our mainframe application tuner and do a sample based on something that's happened in the environment. So as we get into the next level, we get into high automation, this is where we start to utilize analysis, machine learning, and really starting to take that into account in making decisions in the environment. So we actually start to look at thresholds, trending elements, looking at patterns, and then initiating automation off of those dynamic discovered thresholds, those dynamic discovered clusters. And as we start to understand that, and we can understand what type of automation is being run, we can now start to use machine learning to start to provide a recommended prescriptive direction back to someone to make a decision. As we're being asked to do more with less people, as we're being asked to bring new people on board as other people are leaving the organization, we need to have the capability to understand how things have been solved in the past, make recommendations, which allows me to do more, make an educated decision as a subject matter expert, but also as a new production employee, rely on that legacy knowledge that we've talked about being captured in the environment and understanding that John made this decision to remediate a problem in this manner. John's on sabbatical for the next 6 months. I, being the new guy, really respect John. He did it this way based on the system telling me that, yes, let's go off and do the same steps to remediate that. That allows us then to really start to capture some of that knowledge, really start to provide that information back to people that don't have that knowledge to be able to make decisions, and productive decisions, and educated decisions. As we get into that, we really start to do some of those triggers. We talked about that. Really getting into this high automation, really taking into what we reference as sentimental analysis. And that really is augmented intelligence. It's the human element of that. As I was talking about the autopilot example prior to this, there's still a pilot that sits in that cockpit to make critical decisions. We have cognitive thinking that IBM is talking about all the time. Yes, we want to get there. The system's learning from itself, learning from things that's been going on. But there also is those elements that machines just don't understand, that gut instinct. Someone was speaking with me today about Steve Jobs. When Steve Jobs was making decisions about the iPhone, the MacBook, he wasn't using a lot of market data. It was a gut feel. The initial part of it was a gut feel. Now, he had a business acumen after that fact, but he knew the direction he wanted to go. And it's still the same type of thing as we get into an environment that, yes, we can understand the variables that are happening simultaneously in that environment, but they might not also understand that, yeah, I know that marketing all of a sudden kicked off a plan to do some type of advertising, that's why we're having the problem. That type of input is something that we still as a human need to add to that. As we talk about that automation, we start to get to the ability to tell the user some type of prescriptive direction, as I was mentioning. And that user then can take that information, make some type of statement, make a logical, educated decision, and respond back to the environment to remediate the problem. Now, as we take that into that next step, we start to allow that prescriptive information to happen. We allow the system to actually do some type of notification or some type of command into the main system with some type of feedback, and then actually come back into the environment to actually remediate that problem as well. So the key piece is, as we get here, we have direct machine connectivity. So at some point, as we learn more and more, hopefully those less mundane tasks start to become a thing of the past. And the user is actually starting to be removed. Now, when we say removed, that doesn't mean that the user cannot go back and audit the system to understand what is happening. But in the case that I was speaking about before, where John is on a 6-month sabbatical, and Bob's over here making a decision based on what John's done in the past, if that's a recurring issue, why can't I just make it an automated task? So some of the things that we're doing with Learn Remediation, specifically with our product OpsMVS, is being able to look into the logs. OpsMVS can capture things that are happening on the console, people entering information. It understands what specific script was run at a point in time. As we bring into the analytics piece of that, we can start to have that connectivity and understanding and correlation of activity of remediation that was occurring at certain points of time of other variables occurring in the system. What that allows us to do is recommend a direction, take that direction. If that direction is a continued occurrence, just do a check mark, and those steps then can be captured as an automated script. At that point, remediate the issue, document the issue for my audited purposes so I can go back and look at that. But it takes that step out of my daily occurrence and allows me more focus on those things that I need to make decisions about. Subject matter expert, looking at capacity. We want to go to the Z14, what's that going to do for me? Those type of business decisions and those type of elements of things that I don't have time to actually work on a daily basis. So as we get into the full automation, this is where we really get into the system starting to learn from itself. We're collaborating amongst our users. We're providing information, educated information, so I can make an intelligent decision. And we're really starting to get to that closed loop. Now, with that closed loop, we also are probably going to want someone there for those invariable items that occur that may not have been caught by some type of automation in the past. So we still have someone that's overseeing the environment to make sure that we continue to learn, we continue to improve, and we continue to automate as many things as possible. And as we do that, we get the new subject matter expert that has his feet up on the desk, actually letting everything run automatically and hopefully living a more equal personal and work-life balance. So as we get to that, it really is that self-driven element of that. Now, as I was talking about, we're somewhere in the middle currently. We've got a lot of things that we've done from an automation perspective. There's a lot of things that we want to do to make that better. Looking at those logs, bringing that log information, making recommendations. Okay, it's just going to make me as a subject matter expert more easy to make a decision and move forward. Me as a non-productive person or a new productive person to actually add productivity a lot faster. So as we get to that holy grail, really self-driving itself, we look back at a lot of the things that we're using from an augmented perspective to actually add to that mix. We have the automation capabilities, but in reality, to make this, we have to be able to analyze the information that's being provided to us, however that information is being provided. As we talk about anomaly detection or pattern detection, those pieces of information can come in from whatever data element we want to talk about. Data is data. But also data that is out there is the human interaction with the system. What type of data am I looking at on a daily basis? Why am I looking at that data on a daily basis? How can I capture those daily tasks and make them automated? We look at that as one piece of automation for a subject matter expert. Dashboards and reporting. Drag and drop. Let me easily put some type of visualization in front of me because I want to be able to see the information this way because I make decisions based on this information. Now that's not self-driven automation, but that is a piece of automation that allows the information to be delivered to me to make a decision very quickly. Based on that decision, I can then go off and create an automated script. I can create some type of recommended step, and that allows me to continue to build that automation intelligence up in the background. So as we get into this, we talk about automation. It affects each and every element of what we're trying to do. Whether we're talking about efficient process flows, it comes down to cost. What can we save by answering questions faster? What do we save by seeing things earlier in the cycle that may cause an outage in the system? What do we save by reducing the MSU consumption of an environment for you as a customer to ensure that you're getting the software, or excuse me, you're getting the SLA of the workload that you expect at the most minimum price that you have to actually pay? How can we be more efficient in that environment? So a lot of things that we've talked about here is really what CA is talking about from a leadership perspective. If you go out to mainframe.ai, this allows us to actually provide you input and ideas that we're working on a daily basis. You can go out there and look at thought leadership, Vikas and Ashok and those that are in our leadership part of the organization, providing input, providing feedback of information, and just kind of ideas of things that we're looking at. This whole session that I was talking about, the self-driven automation, Ashok did a blog post on this and how that really relates to what we're trying to accomplish in the data center. So as we move forward and we try to make that self-driven environment, we're going to want to bring whatever ideas to the market. They may be good, they may be bad. But as we're doing some of the things we've done with mainframe operation intelligence over the last year and a half, we brought it to the market. We learned from the market. We learned from the users. Same type of thing as we get to a self-driven automation, let's learn from the user, interacting with the system. I want to thank you guys. That's the end of my presentation.